working? Okay, can you hear me now? Yeah. It's like I'm on a podcast. Hey everyone. It's great to be here and to see so many of my friends at my first ever Euruko. What an awesome conference. I'm Joel. I'm a software engineer from Oxford in the UK. And I've got about 30 minutes to cover at least 45 minutes of content, so we might have to go at 1.5x. You're okay with that, right? You listen to podcasts and you're not an animal. So in the run-up to the conference, I got an email from the organizers. And it said, we also have a backup machine available in case of technical issues. Feel free to share your slides at least 1 week before the event with us. So if we have any technical issues today, then I've got nothing for you. It's cute that they thought I'd have slides ready. This is me preparing for Euruko. And this is me doing open source. I can't help it. So here's the thing about ADHD. There's a spectrum that runs from easily distracted via functional adult to hyper-focused. So I operate here, and it's binary. The only way I can stay on track and get anything done is to constantly nerd snipe myself. There are loads of tricks and techniques to nerd snipe yourself into doing things, even boring things. Think about how you'd nerd snipe someone else. I wonder if it's possible to do insert difficult thing. I bet you couldn't insert difficult thing. The key is the thing has to be challenging and high quality. Essentially, it's about aiming higher. Have you ever heard the phrase, perfect is the enemy of the good? It's kind of nonsense if you think about it, because compromise is the enemy of motivation. I think humans want to do a really good job. Doing hard things really well is much easier in some ways than doing easy things. Just want to open this. So people talk about 10x engineers, this idea that some engineers are 10 times better than average. Some dismiss it as nonsense. I think 10x engineers are real, but it's not the engineers themselves, and it's not even the problems that they're solving, so much as the way that they're working on them. 10x engineers are just regular engineers who are locked in. They're nerd sniped. You can't change your boring business problems, but you can aim higher in terms of how you solve them. Here's an example. I think the team at Zed, the text editor, are probably some of the most productive engineers in the world. They ship. And I think a large part of the reason they do this is because they're so ambitious. They're trying to build the best text editor in the world, and they'll move mountains to do it. For example, they designed a completely new UI framework that runs on this GPU at 120 frames a second like a game. I think your average manager would have said that this was reinventing the wheel, something you're not meant to do. Something that will slow you down and distract you from the real task. So I'm here to talk about building beautiful views in Ruby. Before we get into that, I have some questions for you. Just want to kind of gauge who I'm talking to. So who loves reading and writing Ruby? OK, that's pretty much everyone. How many of you would say it's your favorite computer language? Second favorite? Top 3? OK. It's top 2 for me. But I won't tell you what the other one is. OK, it's CSS. People have very strong opinions on these things. I have a lot of strong opinions too, and for the next 25 minutes, I've got a microphone, so strap in. Jimmy's may be rustled. Why do I love Ruby? I love Ruby because it's so flexible. I find it natural to express ideas and create abstractions in Ruby. Ruby is in its own league for this stuff. It's like nothing else. What do I mean by creating abstractions? This is quite difficult to explain. It's about finding concepts and giving them really good names and interfaces, and then moving them away, reducing your dependencies. I like to think of these concepts as sort of existing, whether we codify them or not. The concept of administrationship probably exists in your app, even if you don't have an administrationship model. And you probably should. So it's about naming things. We start with basic logic gates. We build layer by layer on top of that. First assembly, then C, then Ruby somewhere in the middle. And Ruby has objects and variables, garbage collection, floats, integers, arrays, and strings. There are ranges, enumerables, modules, and classes. But this is just the middle of the stack of abstraction. On top of Ruby, you're using frameworks, Rails, and other libraries. And finally, you have your own abstractions for your domain. You might be thinking, doesn't that make a mess? With all these abstractions, how do you know what's going on? It's amazing how many times I've seen this attitude. But it's kind of like saying, with all these drawers and boxes to organize your Lego kids, how do you know where anything is? Wouldn't it be easier if you just threw it all on the floor? Words that have never been spoken by a parent in all of history. Some of you were told that duplication is better than the wrong abstraction. I think that's bullshit. There is no wrong abstraction. And doing the wrong abstraction today, if you're abstracting well, will make it easier to change later, not more difficult, even if it turns out you need to change the abstraction as requirements change. You know what's difficult to change? Lots of code is difficult to change. Well, okay, that's true too, but what I mean is more code is more difficult to change than less code. If you have 20 independent implementations of the same thing, that thing is not easy to change. So that's why I like Ruby. It's flexible when it comes to making abstractions, recognizing innate concepts and codifying them, ultimately making things more consistent and easier to change. Speaking of strong opinions, what's your opinion on Tailwind? I was in two minds about this for a while. To understand why, let's look at how I learned to write front-end code when I first got into this stuff. So here's a pretty typical example of what's often called semantic class names. By naming these concepts, we make them reusable. 5 distinct concepts, 5 names. Kind of ties back to why I like Ruby, right? Did anyone see Adam Wathan's talk at Rails World? Can you imagine his reaction when he saw Action View? Props to Adam. He did a great job of explaining how you can use apply to wrangle semantic classes from Tailwind. And his talk was great. It always amazes me how fast he can move in Tailwind, designing in the browser. If you look at the Tailwind website, it actually recommends multi-cursor editing as a way to handle duplication. I'm not saying this is very wrong, but it's definitely questionable. If we look at another one of Adam's projects, Headless UI, you'll see something like this. This is Vue, by the way. The utility classes are hidden in the implementation of these named components. So my story with Tailwind kind of went like this. Phlex. Phlex is a library for designing object-oriented components in Ruby. It isn't a templating language, though it does have templating features. But the templating in Phlex is structural. It is not string-based. It's also not just the DSL for creating HTML. There have been a bunch of these over the years in all shapes and sizes, and Phlex does draw inspiration from many of them. But Phlex is also quite different from these gems. It's quite unique. So my goal today is to give you a small taste of what's possible, so you can decide to either try it out or that it's definitely not for you. So the heart of Phlex is this direct mapping of HTML semantics to Ruby syntax. HTML has elements. Those are mapped to methods. It has attributes, which are mapped to keyword arguments. You can also nest elements inside other elements, and that's all handled on the Ruby side with blocks. I love HTML, but HTML syntax is just one way to represent HTML semantics. As you'll see later, there are some real advantages to embracing this native mapping in Ruby. However, some people really don't like it. That's kind of okay. Some people don't like Ruby. Here's a real tweet from a couple of days ago. This looks gross, this Phlex thing. It's so unintuitive, makes me cringe. I told you Jimmy's would be rustled. So let's look at some of the features quickly, and then we'll get into a demo. Phlex is designed to structurally prevent cross-site scripting attacks by default. So if you have a link with an href from user data, Phlex knows that it's a link and will ensure there's no JavaScript in it. How many of you really use a content security policy that disallows unsafe inline? Sensible isolation. Phlex components only depend on the data you pass in, making them easy to test and reuse. It also ships with test helpers for Capybara, Nookaguri, Nookalexpa, and Minitest and RSpec. It has no dependencies, and the Rails extension only depends on Rails itself, technically railtie. Phlex can stream responses, so bringing time to first byte down. In some case, users can see the first static content rendered in their browser before the database has even responded. You can render a view targeting a specific set of DOM IDs, and Phlex only does the work to render just the parts you want. So this is great for partial hotwire updates like turbo frames. There's no time wasted rendering the bits of the page that you don't want, and it doesn't send the bytes over the wire. You can also package components up into kits for easy reuse across projects. Kits can be shared with the community as Ruby gems or kept for internal use. Here's a few examples of third-party libraries of components: Flex UI, Protos, and Zest UI, all built on Phlex. It's also fast enough. Phlex renders at about 1 gigabit per second on my MacBook Pro. And it doesn't slow down the more components you extract. There's no need to cache the view. Phlex works great with Rails. It supports all Rails helpers and plays nicely with ViewComponent, ActionView, Stimulus, Turbo, and Tailwind. You can render view components and ActionView partials in Phlex and the other way around. And it's just Ruby, so you can use your existing skills and dev tools, things like Ruby LSP, Solograph, RubyCop, SimpleCurve, RubyMine. They all work. So what is a component? Let's look at a typical web app. There are 54 icons above the fold. I think each one of these is a component called icon. I think that makes sense. They're all different instances of the same kind of object. 14 badges. There are 13 buttons, 2 avatars, a header, a file explorer, a sidebar, a menu. This is the point where I have to switch my laptop to mirror my display. OK. So for a live demo, let me go full screen on this. So I don't have time to show you Phlex in Rails, but this is a quick demo of some of the basic features. So we start with a class. This one's just called example, and here we're rendering a heading. And it turns into a H1. Pretty simple. I have this kit called components, which is just a module that extends Phlex kit. And I can include that module. I just put an O in. And now I can use components. So I have a component called nav. So our nav component is wrapping this heading in a nav bar. And we don't specify any details about this nav from this example component. That the class menu has been added in the example, in the nav component, which looks like this. So that's basic wrapping. Let's get back to the example, and I'm going to add some links. So let's say I want something like and we'll call this class nav item. And I'm going to add a href, and we'll just put it to slash, let's say home. Now, this isn't great. The example component now, oh, I've got that in the wrong place. The example component now knows how to render nav items. And I don't think this is amazing. I'm just going to save this. It shouldn't really know the details of like the CSS class here, or that nav items need to be an A tag. Maybe they need to be wrapped in a div or an li. So we can take this implementation, and we can move it into the nav component. And we just define a method here called item. And we'll take the text, and we'll take the href. we're going to replace this href with nothing, and we'll just put the text here. So now, back in our example, we can pick up the yielded nav, and we can do n.item. Remember, we had the text followed by the link. So now, this implementation detail, and I'm using semantic classes here, but you could use Tailwind classes, is completely encapsulated in the nav component. There's nothing leaking outside of this, and there's no duplication. And I don't know why I keep switching to the wrong tab. So let's look at another example. Tabs. I've got a component called tab group, and it does the same thing. It gives me t, and I can do t.tab. I'm going to give it a name. Let's call it tab A. And I can give it some content. Let's put a P in here, and let's say hello. So as you can see, similar kind of thing is happening. We've got tabs. Oh, why does it do that? We've got tabs, we've got tab link, and we've got tab content. And I can do this multiple times. Let's change that to B. And we're doing that for multiple tabs. But what if we wanted to have both the links rendered at the top, followed by both sets of content? The way that this is working right now is we start rendering the tab group component. And let me just switch into tab group. We hit the view template. It receives a block. It creates this div with the class of tabs, and it passes the block in. This default implementation is essentially the same as if we just did yield. Except Phlex automatically makes it yield self unless we give it an explicit argument. So when we yield, control is given back to the caller, which is here. And so this allows us to hit this tab method multiple times while it's rendering. And as you can see, we're just outputting this. So if we wanted to output both sets of links followed by both sets of content, we're going to have to do something different. This isn't going to work. So the way that I would solve this is I would first create a record for our tab. So something like tab is data.define. It has a name. It has content. Now, we want to have a list of tabs. And we want to update this tab method to push into that list of tabs when it's called. Something like this. Thanks, Copilot. That's great. So now, when we hit the tab component, we're actually just going to push into this list. We're going to create a new tab each time. And so this list is going to be filled with tabs. But we're yielding at the wrong point here, right? We are yielding in the middle of this thing. So this isn't quite right. We can include Phlex deferred render. If you can think of a better name for this, you let me know. And then we don't want to yield. Instead, we are going to iterate over our tabs. I can do tabs.each, and I can do, yeah, let's do a button. And let's do tabs.each again. And this time, we'll do the tab content. Now, Copilot's got this slightly wrong. Tab content is a block, so we're actually just going to pass it straight in here. So now, we have two buttons rendered first, and then we have two sets of tab content. And our interface hasn't even changed. We're using exactly the same interface. The difference is the block is yielded early, and this is a more strict component. So if we do something here, this will not be rendered. This is like a void context now. So I have one more example, if there is time. And that is table. I'm just going to jump over to my examples MD, and I'm going to copy this one. OK. So I've updated our example. It now has this list of people, which I'm just setting in the initializer here, but obviously this would come from a controller. And then we're going out to this table component. We hand the table component the people, and then it yields itself. And then we call column, and we give it a header and a block to calculate the body from a single record of a person. So we can just add t.column email, and immediately our whole table is rendered with the names and emails. So doing this in something else would be quite tricky. You'd have to, everywhere you use the table, you'd have to iterate over all the headers first for all the columns, and then you would have to iterate over all of the body text. And you'd have to try to keep those in sync. Whereas given that this is just in our table component, we can iterate over those columns once here, and we can iterate over the rows, and within that, iterate over the columns again, this time calling the content with our row. Another thing you can do in Phlex, and this isn't a great example of this, but anywhere that you see something that you want to summarize, like this piece of text, this piece of code, really all I want to do when I'm looking at it from here is just see that it is the head, right? So I'm going to delete it, and I'm going to say render head, or let's call it header. And then I can just create a private method. I'll paste it in here. And it still works. It's just Ruby, so all of the normal refactoring that you would do with Ruby works just fine. You can imagine really big views could just be a nice table of contents at the top, and then you can use your symbol navigation to jump to the relevant parts. And it just becomes really easy. Another thing you can do is a bit cheeky, though there are ways you can do it that are less cheeky, is let's say I want to wrap this TD. I can actually just define TD, and I can call div and then super. I don't know why you'd wrap a TD, but we get to put a div outside of the super. And in fact, we can do something inside it as well. Yeah, so what you probably want to do actually is have a different method that calls a TD in here, and then use that method here. And that would allow you to inherit from the table and then layer on some extra functionality. So you could customize how TDs are rendered out, adding a class or something like that. So that is the end of the demo. I'm going to switch back to my presentation. And I have to stop mirroring. See if we can get back into this. So building views in Ruby allows you to create simple abstractions, avoiding duplication and inconsistencies. They fully encapsulate specific responsibilities in the view layer. You can yield a flexible interface with in-order or out-of-order slots. Component kits make components more portable, easier to use and share with others. Plus, you can install existing kits in your own app. You can use one language instead of 3, ERB, HTML, Ruby. And compared to view components, one file instead of 2. Heck, you could put multiple components in the same file because they're just constants. And finally, it's fun. If you try it, you might like it. What's next? I'd really like to build a language server. That would allow us to offer things like autocomplete for HTML elements and attributes, go to definition for components, and optional Tailwind autocomplete, even when using conditional CSS classes. Additionally, source maps would allow us to build dev tools that allow you to inspect components in the browser and just jump straight to definition in your code editor by clicking on a component in your browser. Flex.js and more Flex. Similar to Turbo, Flex.js, which we're working on, will take advantage of Flex unique capability of selectively rendering on the server. More Flex is a DOM morphing library that we wrote to support Flex.js. Its algorithm is top to bottom like Flex.js, sorry, like Flex, which means we should be able to support streaming DOM morphing. Forms are the trickiest components to build in Rails in my experience. I would really like to share some generic abstractions to help with this. So that's something I'll be working on soon. And finally, first-party component kit. We've got Flex UI, Protos, and Zest UI. I have finally decided that I am actually going to build a first-party component kit. I'm not sure what it's going to be called, but the who was it? The Laravel people who made a component kit called Flux, spelled with an F. So maybe that will be some inspiration. If you want to find out more information, there's a link here to the beta website. Flex 2 is releasing probably today as a beta. And there's also a link from there at the top right-hand corner to the Naming Things Discord channel. Thank you.